to the two-lane roundabout when capacity is necessary. So when we look at we're going to switch gears here to more of the transitional and high-speed applications and how important driver expectancy is. Okay? We know that as an industry, our roadway design standards are predicated on that, our highway design standards for speeds and curves and sight distances, etc. But with roundabouts, we sometimes ignore those things. So here's a project that has, its placement is out of sight. So you have a rural highway that people are driving miles and miles and miles without any interruption, and we suddenly put in a roundabout that's basically out of sight on that approach. Now, if you're local and you're used to this, it's probably not a problem. But what if you're not from the area? What if you're visiting friends or family, you haven't been there in 5 years, so all of a sudden there's something there? So that could be challenging. So here's a revised placement and design, associated design. That puts the roundabout in the driver's line of sight on the approach, both from a distance and as you get closer. So this therefore adheres to the driver expectancy principles, provides a terminal vista, and you're going to have a much less chance of someone missing that project, like occurred at this project that recently was on the roundabout listserv. So you can see on this approach, the roundabout is offset. Perhaps there was constraints on that north side that they were trying to avoid, and they put it there. But someone missed it, and they ran into some rocks in the central island. That is another issue we're going to talk about in a moment. But you really want that roundabout in the line of sight. And there's other mitigations that you can do here when it's not right in the line of sight as well, which we'll talk about some more. So landscaping of the central island on these high-speed roads, you don't want fixed objects in this. You want a mounded, you want to use clear zone type vegetation appropriate for your area. And these are based on science and principles across really international as well as in the U.S., North America. Here's a high-speed example. You're coming off of Highway 151 there, off to the right side of your screen, and you split off onto U.S. Highway 18. So you're coming off a 65 mile per hour facility onto a 55 divided two-lane road that was pre-roundabout, a side street stop control that had lots of crashes, bad crashes. And you can see some of the slight alignment changes that we made to square up the intersection, which then allows for sight line, ability to provide good sight line on both the approach as well as you get near the intersection for good target value and conspicuity as you approach that roundabout. In addition, it's heavily landscaped. So when I was involved with this project, when I was with WISDOT, it was, well, we need to change the character of this. They were going to put in an interchange here to resolve the bad crashes, but the town didn't want to interchange, and there was environmental issues and lots of issues with an interchange. It certainly would have solved the crash problems, but it was really expensive and impactful. But so we talked about changing the character on the approach. And I've had colleagues come up to me afterwards, Bill, what's the deal with all the landscaping? We don't usually do landscaping. We're the DOT. We don't want landscape. We don't want maintenance. But if we go back in our industry, there's a lot of discussion early on about changing the character and using landscaping to change that character. Okay, so this is what we did on the approach. Particularly, you can see it there up to on the north side or at the top of the picture. Appropriately sized caliper trees based on clear zone and breakaway considerations in both directions. There's also advanced intersection lighting. We mentioned the landscaping, the channelization, the entry angle, speed control. All those are also met as well. So here's the example number 2 of this is the Stark County State Route 619 McCallum Avenue Safety Improvement project. And here's the location of it. Off to the left there is Akron, north, and then I'm not sure what's to the right. Can't see it anymore. But you can see the yellow dot there. It's out there in the in a rural area. You can see the curvature of the roads and the sort of the context. There's some driveways, residential. And as you look at these photos, it's currently a free flow condition. It's, you know, it's pretty wide open, but there's curves. The roundabout is on a curve and on a skewed intersection. So there's some challenges here with this application of a roundabout. Again, free flow, state routes 619, and we're going to put in a roundabout. Okay, so the original design came in and it looked like this. And so we'll just step through some of the design principles for safety that I find in the review. So you can see that the angles are skewed. You can see there's, you know, the roundabout is out of sight. There's some issues with perhaps some right turn speed control. Not a big issue here. There's no pedestrians. But driver expectancy is a big one on this project. In addition, you know, we have to maintain, the design has long splitter islands on the main line, which is good. That helps mitigate the application. But they have also long splitter islands on the side street, McAllen, which precludes driveway access and may make more impacts. And those may not be necessary. The driver expectation north-south is a stop sign. Now, has been for a long time. In addition, it's a squared up. Also, it's got pretty tight curves on these approaches, a little too tight. You know, the joke is the milk truck will come through here and you have butter by the time it gets to the roundabout. So you need you know, appropriate curves for the speeds and the context of the project. You can do that in a slower speed environment, but on a high speed, you may end up with some loss of control crashes that would be bad. There's other design details. You know, circuitry widths are not conforming to what we'd like to see. And so there's some overall compositional issues with the geometrics of the roundabouts. So what we want to do is address context and driver expectancy, visual conspicuity, maintain the longer mainline splitter islands, but we'll want to mitigate the skew and the curve, provide early advance indications of the changing conditions up ahead. And we probably can shorten up those side street splitter islands to both reduce costs and impacts, but maybe more importantly to maintain access for the residents that are currently there. So the optimization process restores the safety for both the context, driver expectancy issues, as well as the specific geometrics of the roundabout. And that's what it looks like after it's been redesigned. You might notice it's non-circular. I haven't listed the exact ICD because I'm trying to de-emphasize the specific size of the roundabout and emphasize you use that shape and size and placement, that flexibility to meet these design principles. There's an overlay of the original with the redesigned, optimized design. And you can see we wanted to maintain similar impacts in terms of right-of-way, etc. And costs as far as limits and those sorts of things, which we were able to accommodate. So now we have much less curvature on both approaches. We have a squared up leg that was previously skewed. Our right turns are slower. We have appropriate circuitry widths now at about 20 feet. We maintained the longer splitter islands along the main line high-speed route. We shortened the splitter islands for the side street that was previously stop control or currently stop control. And it's guided by principles. It's not necessarily guided by criteria. We also meet all the safety performance design checks for trucks, speed control, etc., sight distance, those things that are also very important. And there's a look at the final design completed by the prime consultant that I'm working through on this project. Oh no, it's a DOT-led design project, excuse me.